In this video, we're going to start chapter 10, where we compare two populations or groups. In 10.1, we're going to focus on comparing two proportions. So remember, we're going to be thinking P or P hat. There are four objectives to this lesson. 1, you should be able to describe the shape, center, and spread of the sampling distribution of the difference of two sample proportions. You should determine whether the conditions are met for doing inference about P sub 1 minus P sub 2. You should be able to construct and interpret a confidence interval to compare two proportions. And you will also be able to perform a significance test to compare two proportions. So let's start with the basics. In the last two chapters, we have been focusing on creating confidence intervals and doing significance tests with population proportions and population means. In this section, we're going to talk about when we have two populations or two groups. So if we're comparing the proportion of individuals with a certain characteristic in population and population 1 and population 2, those are two parameters of interest, P sub 1 and P sub 2. We would take a separate random sample from each population and then compare the sample proportions with that characteristic. It could also be two treatments that we're comparing, a placebo group with a treatment group. So the parameters P1 and P2 that we want to compare are the true proportions of successful outcomes for each treatment. We use the proportions of successes in the two treatment groups to make the comparison. So, just like before, the parameter is P sub 1, P sub 2. The statistic is P hat sub 1, P hat sub 2. And the sample size is N1, N2. The sampling distribution of a difference between two proportions, let's just take an example. If we have a sampling distribution of the difference between two proportions and we have two known proportions of successes. At school 1, 70% of students did their homework last night.
Bus 371 has just arrived. The students are signing in and will be reporting to class. Thank you.
At school 2, 50% of students did their homework last night. A counselor at school 1 takes a simple random sample of 100 students and records the sample proportion that did their homework. School 2's counselor takes a simple random sample of 200 students and records the sample proportion that did their homework. So they're not exactly the same, but we're comparing two different schools. What can we say about the difference in P hat sub 1 minus P hat sub 2 in the sample proportions? So using Fathom software, they created a simple random sample of 100 students for school 1 and a separate simple random sample of 200 students from school 2. So here's our school 1, here's our school 2. The difference in the sample proportion was then calculated and plotted, and we repeated this process 1,000 times. Here's the difference. Notice all three of these graphs look semi-normal. They look like they have approximately normal shape. So the shape of all of them are approximately normal. Look at the center. The center for our first proportion of 100 students is close to 0.7, the population mean. The center for the second group, the second school, was 0.5, also the mean of the second school. And notice that the center for the difference is 0.2, 0.7 minus 0.5. And then the spread, if you remember back from previous chapters, to find the standard deviation, it's P times Q divided by N, and we take the square root. Well, with the spread, we can't just subtract them. If you remember, we have to do the variance and subtract them, add them together, and then take the square root. So the spread is not subtracting them. So the sampling distribution of a difference between two proportions can be basically summarized with this. We choose an SRS of size N1 from population 1 with a proportion of successes P. An independent simple random sample of size N with population 2 with a proportion of successes is p sub 2. The shape, when n times p and n times q, we've been calling this q, and n times p and n times q for population 2 are all at least 10, the sampling distribution of the differences is approximately normal. The center, the mean of the sampling distribution, is taking the proportions and subtracting them. And the spread, or the standard deviation of the sampling distribution, we have to take the square root of p times q divided by n plus p times q divided by n for the second population, as long as each sample is no more than 10% of its population. Remember, the 10% condition will also have to be met. Here's an example of what that sampling distribution should look like. We have a center, which would be the differences in the mean. The values from p hat sub 1 minus p hat sub 2 would take up this whole line. The mean is the center of the population. The standard deviation is how we find one standard deviation away, and this purple line represents the sampling distribution, all possible values. So let me walk you through an example. It says, suppose that there are two large high schools, each with more than 2,000 students in a certain town. At school 1, 70% of students did their homework last night. Only 50% of students at school 2 did their homework last night. The counselor at school 1 takes a simple random sample of 100 students and records the proportion that did homework. School 2's counselor takes an SRS of 200 students and records the proportion that did homework. Describe the shape, center, and spread of the sampling distribution. So, first, we take n sub 1 times p sub 1, 100 times 0.7, and we get 70. N times q, which is 100 times 0.3, and we got 30. Then we did the same thing for the second population. N times p and n times q. All of these are at least 10, so the sampling distribution is approximately normal. That means the mean of the population would be 0.7 minus 0.5, which is 0.2. And the standard deviation, if we take the square root of this formula, that's how we got the 0.058. So the shape is approximately normal, the center, the mean is 0.2, and the spread is 0.058. When data come from two random samples or two groups in a randomized experiment, the statistic p hat sub 1 minus p hat sub 2 is our best guess for the value of p sub 1 minus p sub 2. We can use our familiar formula to calculate a confidence interval for this difference. Remember, it's the statistic plus or minus the critical value times the standard deviation of the statistic. So, as long as the 10% condition is met, the standard deviation of the test statistic is p hat sub 1 minus p hat sub 2 would be, we already did this, if the normal condition is met, we can find a critical value, z star, because we're talking proportions, for the given confidence level from the standard normal curve. So we would go and we would find our z star depending on what confidence level we are interested in. When the conditions are met, an approximate conditions for constructing a confidence interval. So first, we know from previous lessons, it has to be random, has to pass the 10% rule, and it has to pass the large counts rule. N times p, n times q. Have to all be at least 10. Because we don't know the values of the parameters for the population, we replace them in the standard deviation formula with the sample proportions. The result is the standard error, which is the same equation as the standard deviation, but we're using p hat and q hat. So when conditions are met, an approximate c% confidence interval for p for the differences is, take your difference, add and subtract our z score times the standard error.